And for those who aren't familiar, Datalog is like a query language specifically for like triplet like data stores or like these
Hmm.
like Datomic uses Datalog. So can you tell us a little bit more, one about the query language and sort of what your goals for that are? Um,
Hmm.
like two, like why write your own query language? I know we talked
Yeah.
a little bit about like SQL and not wanting to run SQLite. So yeah,
Hmm.
maybe take those.
Sure thing. Um, let me kind of form the thoughts. So I think the first thing is um, maybe why Datalog, and then maybe why something on top of Datalog. Because the first thing that I wanted to kind of mention is the triple database under the hood. This is not something that we necessarily like. We want the user to just feel very productive, and they shouldn't have to worry about the underlying data structures. Like kind of similar to Postgres in a way. Like when you add an index to Postgres, you kind of know the data structure underneath, but you don't really know. Or, and when you run a query in Postgres, it can do so many amazing things, and you just it's like having like a mathematician in your team that's doing the exact right thing to write your queries until it's not, which we can also talk about too. Um, so so that the way that we want to make all of this right, we don't want to kind of I also believe in this one thing where you need to meet developers where they're at. So there are some things that are important to tell somebody because it's like an expertise thing. Like you need to, if you want to be a great guitarist, like you need to know some like unique thing about the guitar. But for some things, like I don't think you need to know the underlying structure too much on this. So what we wanted to do is we wanted to give people like when you're writing things in TypeScript, you naturally think about things as objects and relationships between them. Versus if we just went with a pure triple approach, you actually there are no objects. There are these aggregations of objects, which is an elegant idea, but it just contradicts very deeply with TypeScript. So what we wanted to do was, look, let's give people something that is the most convenient way to fetch, to describe what you want. And in my opinion, one of the most convenient ways is GraphQL. Like users post, boom, right? Writing that query in SQL to get that data structure back is actually, I would say, intermediate SQL, right? The very basic one is a join clause, but if you want to aggregate each post under a user, you have to use JSON or JSON ag, and I think most people don't do stuff like that, right? So I think GraphQL really makes things a lot simpler. But the problem with GraphQL is twofold. One is it does add this extra build step, and I do think that really impedes productivity when you're getting started. And the second thing is, it's really nice when when you can modify, your language, JavaScript, for example, or TypeScript. It's great at modifying data structures. It's not great at modifying strings or things like that. So it's very nice where instead of doing like this compiled like AST node thing, all you're doing is just taking an object and let's say you want to create a table where you do filters, right? Now you can just construct your query as the user changes buttons, and it's a really delightful experience. So I wanted to give the user this power. Like it's very frustrating in my opinion. In most languages, like for example, SQL, you cannot do this, right? You cannot. It's usually a string, so you have to kind of think about how you're going to generate this. But we didn't want that. We wanted to make it something. It's a real data structure that you can use functions to generate your query. Uh, and then why not, but in order to run that query, how do we run it? All right. Well, under the hood, because it is a triple store, one of the most elegant ways to run queries on a triple store is using Datalog. And the reason is Datalog is this much smaller language compared to something like SQL, but it is equivalent. Like you can do almost everything you can do in SQL. You can do, I think theoretically you can do everything. So that's what kind of let us say, okay, under the hood, we have this triple store. We have this language on top of that, which um, which lets us easily query into it. But then we give this layer on top for users, which are pure data structures, which give them the data that they expect, which is objects and the relationships.
So was using Datalog under the hood, was that so that you could leverage existing like query optimizations or like do like pull some off the shelf like libraries or something in order to not have to re-engineer that versus just like having your query language directly compile down into, I don't know, something that does the data fetches specifically?
Yeah, the main one was it's kind of like I really believe sometimes, for example, DSLs get a very bad rep in the programming world because you can do them wrong and they can be very painful. But I think if you do them right, they're very, very good. And you can actually see this, that like most of the most useful software are effectively DSLs. So the way that we look at the data log is kind of like this intermediary structure that we that's easier to handle. So uh, what that lets us do is instead of, for example, let's say we wanted to compile directly to SQL, that would create on Postgres this very giant CTE. But and then on the front end, we wouldn't be able to compile to SQL. We'd have to just kind of run those manually on the data store. Uh, but the nice thing with this intermediate structure is now on both sides we can have a lot of focus on generating this intermediate structure, and then running a data log engine is, I would say, reasonably simple initially. So if you wanted to, for example, do a hackathon where you write a query engine, guaranteed you can do it in Datalog. Like I have a blog post, you can read it, and at the end you'll have a query engine. If you try to do that with something else, like if you want to try and make your own SQLite, I think you'll have a tougher time.
So a through line I'm seeing in kind of like all the stuff you guys put out is making complex topics really simple and easy to consume. Like even in your on your homepage, you're like, hey, there's fetch. Why don't you just use that? And then you're like, oh, well, there's all these problems you'd have to think about and you don't want to worry about. Another topic that kind of is in that same area is permissions. You
Mm-hmm.
guys call that out very explicitly in your docs as something that you wanted to make better over Firebase. So,
Mm-hmm.
like, what were the shortcomings of Firebase, and how have you fixed those in your new system?
Yeah, so I would say, and like where at least where permissions was inspired for us was another kind of ex Facebook story. So inside Facebook, there's this library called the Ent framework, and they did a very interesting thing with how permissions work. First, you write permissions in a language that in the same language that that you write other things in. Second, the permissions are written at each object. So there is no way for a developer to write a query where they can see something that they're not allowed to see. So every query you can think of takes in an argument called the viewer, right? So it's either a user or a page or something like that. And the reason they did this is, you might think that the simplest way to do this is every endpoint has like an if statement. Can you do this endpoint or not? But the problem is when you get more and more engineers, this just starts to break down. Like you do not want to have any privacy violations. Given the reputation of Facebook, you would think that we would be willy nilly going doing that. No, no, no. We really did not want that. So we worked very hard to make sure that that wasn't the case. And one way you can do that is to push the complexity down to the object level. I think Firebase, um, honestly, as I go through it, I think maybe I was too mean to Firebase originally. I think they actually did a reasonable job. I think the problem is it just gets tough. You're writing these strings. There's these kind of gotchas about, because it's a document model. It's unclear. If a permission level fails here but passes at a parent, what should happen? And technically, what actually happens is the parent passes, and you just get all the data. So it's easy to kind of mix up. But what we really wanted to do with Instant was to kind of give you this object level permissions. Uh, Turns out Firebase has a great sub-language called Cell, which Google made open source. And we use something similar we use it to generate our permission rules. Um, but I think the big thing, or the big like aha, is I think it is really important to put permissions at the table level, basically, because what that allows you to do is you now no longer have to worry what kind of query can be written. right? In 6 months, if I make a new endpoint, like, will I add in a security vulnerability? No, it's impossible because you can only get data you're allowed to see.
Yeah, it's cool. I like how like consistent it all feels too, and it's nice to have it all sort of built in the same uh, like language, especially because I've definitely worked with
Yeah.
like obviously different query languages, but then different policy languages, and like having to
Hmm.
jump through a bunch of like DSLs and different tools, or like maybe they need
Yeah.
build steps or they compile or their extra libraries or whatever. All of that stuff
Yeah.
can stack up to not only be a maintenance burden, but also like be hard to piece together like how everything fits together. So I think packaging everything up for instant like this is pretty nice.
Yeah, it definitely took a lot of research. I would say for permissions, to be fully frank, I think we still have a long way to go to make that really good. But kind of to give a next, like a goal, like a start of where we're headed is, when we were doing this research, some of the simplest ways you could solve this problem is to do, for example, role-based security or ACLs. But the problem is eventually you hit these issues where you cannot express what you need to express in these languages. So you kind of duplicate your data model from your database into like an ACL. Uh, so we didn't want that to happen. We wanted it to make it so that you can express the relationships about who's able to see what, and it's in a single place, like your database. Um, so that's kind of where we're headed right now. I think we still need to add like better, like another thing that I love is like Rails active record. In my opinion, has this really beautiful way of describing how an object looks, validations for an object. Oh, this email has to be past this regex and things like that. So eventually, we want to get to something that looks kind of like active record.
So uh, that's pretty cool. I mean, I think Active Record is a good target because of like how like pretty straightforward it is to implement.
Yeah.
So like what is like an authorization setup inside of InstantDB? What does that look like today? Can you just like sort of walk us through
Yeah.
like if you're trying to set like up some basic auth flow or
Yeah.
permissions, whatever?
So here's how it works. First, when you start off, we make everything permissionless. So you can start hacking, make things work the way you want. Once you're ready to add auth, there's like a quick start. You copy a quick start, you can get magic code emails working right away. You can get signed in with Google. There's an integration with Clerk. So now you have authentication. Once you have authentication, right? Well, now you can write permissions based on this authentication. Uh, you can also write it without having authentication, but I'm kind of walking you through the steps that you would normally go through. And then there's a kind of like a mini language where you can write special rules on each object. So you could say, okay, I want to make sure that a post can only be edited by the owner. So you could say a rule like auth.id is equal to post.owner. And then boom, no matter what kind of transaction comes into the system, we're going to guarantee that invariant for you. That's the outline.